Quarkus Insights, Episode 19, the Hackathon IoT winner with special guest Joe White. Hello everyone, sorry for the delay in starting our show today. We've had some technical difficulties, so please bear with us. We'll try to keep the show as interesting as possible as always. So welcome to Quarkus Insights, where we talk about the latest happenings in the community and do deep dives into interesting Quarkus technology. I'm your host for today, Jason Green, Quarkus co-founder, and I have an excellent panel and of course a very special guest, because with us today is Joe White, who's going to be talking about his submission to the Quarkus Hackathon contest, which won the best IoT application category, as well as tied for second place in the overall. It's also a fantastic demo if you want to take a look at how you could build a digital transformation like use case using Quarkus and other technologies. So before I head off to the panel, introduce everybody, I'd like to go ahead and show you Joe's original entrance submission. So here we go.
Welcome to the Quarkus Hackathon presentation for IoT for population health. This is a serverless architecture for population health decision-making. Population health is evaluating and taking action on health information for a specific group of people, like employees of a company, a specific region, or a group with common characteristics. Health IoT devices are ubiquitous. It's a diverse ecosystem with different data formats, different data access, and different data delivery. Our architecture takes advantage of three Quarkus services: a serverless ETL service to process data and send that data to a serverless decision service using Kogito deployed on AWS Lambda. And finally, we have a Quarkus-based dashboard for analytics and user actions. The serverless decision services are the real technical innovation in the architecture. They enable business users to build and deploy functionality in a complex architecture like AWS Lambda, starting from a spreadsheet. You can go from business logic to running an AWS Lambda function with almost no code. The Health Data Transformation Service is a Quarkus microservice that normalizes data from multiple sources for the rest of the architecture. Being serverless allows it to scale up and scale down under bursty load. In the demo, we'll do a live data fetch from Google Fit. The Population Health Dashboard exposes a set of APIs to allow us to capture data from the rest of the architecture and display that data to a user using Undertow deployed in a Quarkus microservice. We use the architecture to demonstrate two business cases, one for wellness programs to create employee reward systems based on health IoT data, and the second, a population health monitoring and alerting system to capture information from a population and generate alerts based on the data that we see from that population. Now we'll transition over to a demo of the system. The demo starts with the Health ETL service. We'll authenticate to Google and then reach out and fetch pedometer data from my personal Galaxy S9 device. The first step is hit the register button in the upper left. That will redirect us to Google to authenticate and sign up for the health data service. Behind the scenes, the service fetches a long-lived refresh token that will allow the microservice to continue to fetch data on behalf of that user on a recurring basis. Now we'll jump over the logs and take a look at the data that we fetched. As you can see, the system is configured to fetch the last 10 days of data. Don't judge me, I haven't been walking much because I've been working on this. Up next, we'll take a look at serverless decision services using Quarkus and Kogito. For the demo, we've deployed our Quarkus Kogito microservice as a Lambda in AWS. Jumping out to the AWS dashboard, you can see we have our Quarkus Population Health Decision Service deployed as a function. We have the ability to interact with it, see invocations, look at the monitoring and CloudWatch metrics. We can see that we've invoked it recently as part of the setup for the demo. Next, we'll take a look at the business rules deployed in our Quarkus Kogito microservice that we have running in the Lambda. We have rules for steps based on pedometers, active minutes, and then we have alert rules at the bottom based on heart rate and respiratory rate that we could get from other IoT sensors in our health environment. Next, we'll demonstrate invoking those rules both at our Lambda and also in a local environment. As you can see, we invoke a local API. We hit the endpoint and we get a reward back. If we switch over to the decision table, we can take a look at the rule that we hit as part of that invocation. And as you can see in the decision table, if you pass in more than 12,000 steps, you hit the 12,000 step rule with a value of 100, which is the same as the API response that we got back. And finally, we'll take a look at the Population Health Dashboard, which is a Quarkus microservice taking advantage of Quarkus's ability to serve static files and JavaScript. Inside the dashboard, we have a rewards dashboard, an alerts dashboard, and then tables showing detailed data from the alerts and rewards that we get from the business rules. The two dashboard graphs are mocked at this point in time, but the data in the rewards data and alerts data sections is live. We also have links out to the GitHub and technical documentation that goes with the IoT population health project. Demonstrate everything end to end. We've got our healthy data ETL and our decision services running in our command lines and the dashboard behind the scenes. We trigger the data ETL load. As you can see, we get step and rules data. And then if we go back to the dashboard and refresh, we get the health rewards data from my device. In that very fast demo, we went all the way out to Google Fit, used the refresh token, fetched data, brought that data back, invoked the Fit APIs, invoked our business rules, invoked our decision table, and then published that data to the dashboard, all using the Quarkus microservices we looked at earlier. And finally, there's a health data mock service built using Quarkus that allows us to invoke the decision services without fetching live IoT data to simplify testing of rules and to simplify testing of setup. So as you can see, we invoked that mock data service and we hit some alert data that we didn't have in our prior demo. I'm also happy to note that I was able to contribute to the Quarkus core as part of the hackathon with that pull request right there. I found a bug and was able to fix it and get my pull request merged back into the source. This has been a presentation of a population health architecture using Quarkus for the Quarkus Hackathon. Thank you for hosting and looking forward to seeing the results.
Hello, everybody, and here we have our panel here. Yes, and fingers crossed that we all stay connected. So just introducing real quick, we have with us Max Anderson, who is the lead of Quarkus Developer Experience, original creator of the Quarkus Insight show, and former project lead for JBoss Tools, which was an awesome set of IDE extensions, and of course, incredibly importantly, founder of JBang. so hello, Max.
Hello. Hello.
And then with us we have, of course, the Quarkus Hackathon IoT winner and second place overall, Joe White. Also Quarkus contributor and, if I remember correctly, CTO of Entando. Is that correct?
Yep, that's right.
Awesome. So Joe, could you tell us a little bit about yourself and how you got involved in Enterprise Java?
Sure. So I've been a developer or involved in engineering for about 16 years now. I've done Java the whole time pretty much. I've worked in healthcare, defense, and in consumer applications, and now I work at Entando. So I've been doing enterprise Java for a long time. I'm a Drooler user going way back, which resulted in my interest in Kogito and as we did in the hackathon. And today, as you mentioned, I'm the CTO at Entando, so I do a mix of architecture, community growth, community development, a little bit of technical stuff. But the hackathon was a way for me to get back to some technical roots. I haven't written code on a full-time basis for a while, and it was great to have a chance to do that for a few weeks, to dive back in a little bit.
Okay. And how did you get into Quarkus? You took the hackathon or something before? Or?
We've done Quarkus here at Entando in the past. So we use Quarkus for run-to-completion jobs inside of our operator. So we have some very lightweight Quarkus services that we boot up in Kubernetes to do specific tasks like initialize databases and things like that. But I didn't get a chance to work on that myself. And then I was looking at how, what's coming up in the Java world, kind of looking forward from an architecture perspective on new things that are out there and available. And Quarkus came up, and some of my team, mentioned the Quarkus is really interesting, and how can we use it in our architecture? And then I saw the hackathon by chance, and decided that it would spending a few nights and weekends seeing if I could build something interesting, learning a little bit of it. I hadn't personally used Quarkus before prior to the hackathon, so it was a chance for me to learn. The best way to learn is to build something meaningful, and so I dove in.
And did I get it right? Did you said you're writing a Kubernetes operator in Quarkus?
The operator is not in Quarkus. The operator is in Java using Fabricate. But we have the operator spawns run-to-completion jobs, and we use Quarkus for that. So we have some lightweight jobs that the operator kicks off that are built using Quarkus. Because really light and fast to start, and they're things that we need to boot up as part of our application initialization. So for example, we initialize databases, and we do that with Quarkus.
Yeah. Okay. So I'm finding it a bit funny because just last week we had some conversations around using Quarkus as an operator. because now we can make it native and faster set up and kind of thing. And people are like, no, you don't. No one would ever use Java for an operator. And you now saying that you're not even using Quarkus, you're just using plain Java for your operator, and that's fine. So,
and it works great. I mean, it's really, really powerful. You know, we probably had the conversation that probably a lot of people have. You know, should we go learn Go and write Go to do operator? But we found the Fabricate client for Java out there. It was expressive enough to do what we need to do. So we have a full Java operator. It does a lot of stuff too. We have a platform, and our operator does things like allows you to create a microservice. It'll automatically deploy your microservices, instantiate databases, populate the databases, run liquid-based commands. It does full application lifecycle management. So maybe a future Quarkus Insights. We'd love to talk about what we're doing.
I smell
sounds awesome.
Because just so you know, I don't know if you know, but there are actually example of people who use Quarkus, because the client we have in Quarkus to talk to communities is actually the Fabricate communities client. So there are actually people who've done what you're doing, but just use Quarkus and then compile it down to native to get their the win from that.
Yeah, Fabricate's great. It works really well for our use case and kept us in the Java world. So, you know, it makes everything look the same from a day-to-day basis. So it's been really powerful.
Yeah.
That's awesome. And I have to say, when when I was looking at your submission, it was pretty impressive, like how many different sort of technologies you put into that application. Is that something similar to the kind of stuff that you would build in your environment, or was it just more of like the scenario and you really wanted to build out the scenario that drove you to include everything like that together?
It's a mix of both, you know. So I think we focus on building microservices, or the extension point for our platform. So we provide a platform with a bunch of functionality that we could talk about all day. Platforms with microservices, and so I had to build something that eventually, in the fullness of time, I could port over to the Entando platform. But at the same time, you know, I was just learning about Quarkus from scratch. So I started from zero. I knew I wanted to use Kogito. That's the only thing I came in with kind of a prior. And everything else I just picked up from the documentation and as I went. And the thing, you know, something that surprised me as part of the hackathon was how nicely all of the pieces fit together. Like, you know, you're used to building blocks in modern Java world. They don't always sync together like Legos, right? You usually have to do a little bit of work to wire this together, to wire that together. And with this stuff, it all just kind of worked. And that was surprising. I'm used to breaking things and having to fix them. But there was a lot of stuff that just kind of came together, either by chance or you know, ecosystem.
But that's good to hear.
But you did find something though, because you submitted patches, right?
Yeah. My pull request. It's a very small pull request, but I added functionality to support AWS CLI 2.0 in the Lambda extension. So I couldn't figure out why it wouldn't work, and it turns out I had a newer version of the AWS CLI, and I was able to go in and add the script to support both versions of that CLI and deploy my Lambda. And also a couple bugs. One of the things, like one of the great things about the hackathon was really how engaging the developers on the team were, and the community in general was. They were genuinely interested to know how things were going. Like I think I was using some things that people were surprised to see, or maybe they hadn't gotten feedback. And I had some pretty long discussions on Zulip with guys about, you know, what's in the docs, what's not in the docs, what did you have trouble with, and you know, community is that receptive to new people or to dumb questions. But they were really, really responsive, and the community was great.
Awesome. So real quick, I just want to let everybody know, all the viewers that are currently tuned in right now, with Quarkus Insights, we like to keep the show dynamic. So feel free to ask, comment any questions, and we'll incorporate them in the show. And we can ask Joe about some of the stuff he's been building. Or if you have any Quarkus general questions, feel free to throw a few of those in there as well.
So did you get more fit? Like,
quite the opposite. I'm afraid my quarantine has added, I think, 20 pounds to my frame, unfortunately. So, you know, since the spring, I haven't done much. And I think that when I did the hackathon, I was walking even less, because the choice was to work on the hackathon or go for a walk. And I worked on the hackathon. So no, I did not get fit during the hackathon, and it has not gone gotten better since. So I think I need to change some things and get out of a quarantine mentality for sure.
Okay. So anyway, what I got from it was like you were collecting the data from your Fitbit or something like that, and then send it through the rules engine of Kogito or Rules, and then you adjusted what's it called, the rewards and so. Is there any, like, do you want to show any specific parts of this that you find interesting that might, we like to show code and people can look?
Sure. Let me do that. So I'll talk really quickly about the picture that we saw in the video, and I'll talk like briefly about the larger motivation, and then we can dive in. The idea behind this was that the target audience for this application, really it's a proof of concept, but the target audience would be an enterprise. So it would be, something like, for example, the PGA Tour. The main motivation for this in the end was when the PGA Tour restarted, there was a golfer named Nick Watney, and he noticed that his Whoop device, which is a health IoT device, was registering that his breathing was heavier overnight. And that triggered him to get a COVID test. He tested positive for COVID and withdrew from the tournament. And my idea was, if I was the PGA Tour, and I needed to monitor all the golfers and all the caddies and everybody involved in the tournament, what would a software architecture to automate that monitoring? How would I capture all that data? How would I process it? I'm going to take action based on it. So, this doesn't do all of those things, but the idea is that you would design something that would support that. So you could take a group of people, which would be this health IoT devices. Maybe they're golfers, maybe they're all employees at a company, somebody with a common set of characteristics, and then feed that data through something that would allow you to make decisions on it. And so, I think from a technical perspective, the goal was really how would I enable an enterprise to take advantage of all this IoT? It'll be more and more, right? There's tons of telemetry and things like that. So, with that in mind, we'll dive into a little bit of code and talk a little bit about maybe how the health ETL service looks, and then the Kogito piece, which I think is really interesting from a technical perspective. And feel free to jump in and revector me as we go here. So
you go ahead.
All right. So this is the health data ETL service. And I will say too, one of the pieces of feedback that I thought was really interesting from the judging of the hackathon was that there's not that much code here, and the reality is there isn't a lot of code here. And one of the things that surprised me about Quarkus is how much you can accomplish with not that much code. So this is definitely a proof of concept, and it's not all the way filled out. But if you use the tools, you can get a lot done with just wiring together different libraries in a unique way.
Quarkus, a low-code environment. Got it.
Yeah, probably not low code, not much code anyway, less code. Things that I thought was interesting in kind of a unique use case is that I actually needed to create a servlet.
Joe, just can you zoom in just like two or three times just for the?
Let's see here.
It's in IntelliJ. You can just do command and then like expand it, make it bigger with the trackpad.
Oh, okay. Well, let's.
Oh, we lost him. So we're gonna make a little dance now, and then
exactly. So we talked about if this happened, because we've been having some issues with this, so our apologies. So important update we can use this time for, right? So we want to talk about bias locking, and here's Joe coming right back in. So while Joe, go ahead and get set up. While you're doing that, we're going to talk a little bit about bias locking. So there's a JDK JEP, which is disabling by default the ability to do bias locking. So that means when you do a synchronized call, the JVM has this extra cool optimization where it can take away the overhead of the lock if you're stuck in the same, if you're actually in the same thread. So it's basically optimization for uncontended access. There's a lot of technical complexity in maintaining this. So the OpenJDK team has decided they want to get rid of the capability, but we're letting everybody know because it might have performance impacts on your application. So if you if you do any sort of heavy concurrency applications and you make use of synchronized, which is a lot of frameworks, I highly recommend that you take a look at this feature. There's some we'll post a link at the end of the YouTube video for those that are interested, and you can go and learn how you can disable it on JDK 11. You could also use the latest JVM. Was it 15, Max? Was the one that
15, yes.
Yeah. So you could use 15, and then it has it off by default, and then see what your performance looks like. I think they'd be very interested in hearing feedback if it causes problems for people. So we're doing our own analysis, but we've only just started. So just wanted to give you guys a quick heads up. And we have Joe back with us. Thanks, Joe, and sorry for you having to bear with this technical stuff. This is pretty unusual for us, but we're happy that you're sticking with it and being a good sport with us.
Yeah, no problem. I think the command.
So I'm going to flip back to your. Oh, go on.
No, I think the command key is kicking me out, so I'm not going to hit that button anymore. We'll see what happens.
Ah, interesting. Okay. That's okay. Well, here you go. You got your screen share back up again.
All right. So I was going to talk a little bit about kind of how the health data ETL service works, and kind of some potential future optimization capability. I mean, as I mentioned a couple of times, this is very much a proof of concept. It's not a fully fleshed out application or anything like that. But one of the interesting parts about this is that I needed a servlet in order to do the OAuth 2 flow from Google. So the application itself goes all the way out to Google, allows you to authenticate, pick your account, and then fetch data back for you. We can do a demo of that in a second. But the example code for that was all based on servlets, and so I grabbed a servlet and I was able to use the undertow capability in the Quarkus extension to grab that data. And so this takes this data, and then it has a service that points out to our rules engine. So going back to the picture, this call right here happens with that client service, and that takes advantage of the Quarkus register client or the stuff from MicroProfile. So the only thing that's required to wire those two things together is this little tiny piece of code here. And what the code does is the servlet itself is managing the OAuth 2 flow with Google. We get the callback, and then that creates a long-lived refresh token. And so Google is basically giving you the ability to store a refresh token for a user who authorizes that data, and then you can use that token over and over again to fetch it. So, from an architecture perspective, the idea would be you'd allow many users to register here. It would create the refresh tokens for those users, and then you as the PGA Tour or as an enterprise who is tracking health data for a group of people have the ability to get that data and fetch it as you needed to. The other thing here, oh, sorry, go ahead.
No, just go ahead. Go ahead.
Yeah, and the last thing I'll point out here about Google Fit is that the next step in this is to expand this set of data sources. So Google Fit APIs give you a lot of ability to fetch data, and they all come from different named data systems. So you could take, for example, we've got activity segments, estimated steps. You can get activity minutes. So you can get how active were you for a number of minutes, and all kinds of different stuff. And so right now, the application only fetches data for a couple of the different data sources from Google Fit. But the architecture itself could be expanded to go fetch more of that information to add new data to the architecture.
Okay. So maybe I missed this. This is just using a pure REST API. You don't load any Google libraries or something for this. It's just pure REST API using OAuth. That's it.
Yeah, exactly. So it's all REST API based. Once you have your token, it uses a Google client. So Google provides an API client for their stuff, and so it is using that Google API client, which is this guy here, this fitness app. So yeah. Calm Google API. So Google's Java clients for all the different APIs they support. So for Fit and Drive and everything else. And so this is taking advantage of the Google Fitness API client to get the data, which that happens right here. So basically just do a builder, tell you want JSON back, pass your credentials in once you finish the OAuth 2 flow. Your application name is something that you configure out in the Google console in the cloud, and then you tell it what data you want back, and it comes back. You can see right here, we're fetching, this is where we get that step data back. So you give it a time range, and then it gives you the step data for that time range.
Joe, I don't know if it's easy for you. Would it be okay for you to make the font just a little bit bigger in the code views?
Yeah, let me see if I can do that here.
That was what he. Oh, there we go. You
Yeah.
worked this time.
Try not to crash. Try not to crash it this time. Hopefully,
Oh, that
that's
was what was killing. Oh, the command key. All right. Sorry. Anyway, go on.
no, all good. So yeah, that's the Google Fit piece, and then I can jump over if you want. We can talk a little bit about the Kogito piece and how that works, and kind of what would be next. Or I can run a demo of this too if you want. We could take a look at how that works.
Yeah, I think Kogito would be a great thing to show. So just everybody who's unfamiliar with Kogito, Kogito allows you to do sort of business rule processing built into your Quarkus application itself. So you compile it into your app, and then you can process process data according to rules. So in your example, Joe, you used a spreadsheet, if I understand correctly, to map out the actual business rules for how this should all get processed.
Yeah, exactly. So put this up here. Zoom in. So this is an example of a decision table. So a decision table is just a special kind of spreadsheet that Kogito rules, legacy supports as well. But it's a way to encode a little bit of logic into a table that can be consumed by a business user. So this is all expanded so you can see the logic itself. But in most decision tables, you would hide these columns or hide these rows. So that the business user is just consuming, the rules, the business user rules that they want to create and show to their end user. And so it's a way, to declaratively create business logic that you can inject into a service. And I think really, I've been a Drools user for 15 years. Created a really big Drools implementation a long time ago on Drools 4 even. And I think this Kogito is like a really powerful evolution, and Quarkus is an important piece of that technology. The ability to create really, really fast rules engines and really, really fast rules services, I think has a ton of potential. Kogito isn't to 1.0 yet, but some of the capability, like the decision tables and the Drools capability, the DRL, from my perspective, technically and as an architect, as you look at how you assemble these things, really powerful. It has a lot of potential. So we'll look at the code too. This decision table basically takes advantage of this health data object, which is just a regular Java object, and it says if the user steps are from this to this, or like it's steps greater than the parameter, less than the parameter, then take this action. So set some reward. So this is that it's a made up use case, but if your company or somebody wanted to say, okay, every day that you walk more than 10,000 steps, we're going to give you $5. We're going to give you a $10 Amazon gift card, whatever the reward might be. The idea would be that you could use the health data ETL to fetch that information, and then this service would make decisions based on that. Whatever your use case is, whatever you wanted to do. So these are the output columns. These actions are the output columns of our business rule. And so you can see we've got a few different tables in here. So some of them based on activity minutes, some of them based on age and heart rate. So like these are the ones that would be more applicable to like that PGA Tour use case I was talking about. So like if your sleep respirations per minute is over some average and your sleep hours was less than something, then issue alert with different types of severity and things like that. And then you would put that out to the dashboard, or you'd make an API call to send that data to wherever you wanted it. And so basically the idea is that you could use Kogito and Quarkus to create really decision services. So services that encode your important business logic and then distribute those actions out to other pieces of your architecture. So if we jump over to the code, I'll start with that object we talked about. So we'll zoom in here. So it's pretty basic.
Yeah. So like if you're sorry to jump in.
Please.
If you're a developer and you're like every time the the business unit has a new set of rules, I have to re-release the new application and like codify all of it. This is kind of a nice way to do it because you can essentially just hand over the spreadsheet, let them add entries, fix it up, and then pull it right into the app, and you're done. So it's pretty nice to have that capability. But yeah, go on.
Just don't make a macro.
Yeah, I think there's a lot of power in the pattern. Like you talked about it, you never know all of the business rules ahead of time. I mean, everybody says we know what we all want our app to do, but it always changes. It's always evolving. You're always going to want to extend it. And so I think you're better off if you can encode some of that really core business logic, the real decision making in your applications in rules, either in DRL, even if you're using the more technical formats of rules, you can encode them in a way that allows you to really focus on kind of the hard parts of your application, focus on that integration, focus on the infrastructure, focus on scaling and monitoring and deployment, things like that. And so business rules and business rule engines are, in my opinion, a really underutilized pattern for building software. And what Quarkus has with Kogito, I think, is unique. It's a special. It has a lot of potential. It's a special.
Very nice.
So to tie that out a little bit, we're binding to this health data object that is represented by this simple beam. So it's just basically you expose a set of values, and then you can add logic based on those values. And Drools does the work to assemble those two things back together. And so this is the object that we're operating on from a rules perspective. We expose an API for that. So basically we have this health data resource that listens to health data rules, and that thing's going to invoke our rules, and then distribute those rules back out to the rest of the world. And so we process the health data, and as I mentioned, for the hackathon, there are kind of two use cases: one for rewards and one for alerts. These are just basic services. So we process the rules, and then we're processing the rewards and processing the alerts. And in this case, we're just publishing them to the dashboard, but they could go anywhere you wanted. And so from a rules perspective, zoom in here. I'm doing this in a little bit of an old way. So I'm actually invoking Drools automatically. The Kogito has a piece of capability, and if you're new to Kogito, follow their documentation because they'll automatically generate that resource for you. I wanted to do it a little bit differently so I could capture some of the responses and take custom actions. So there's an even more automatic way to do it. But this is what the logic looks like to invoke those rules. It's pretty simple. You get the data from the endpoint. The ETL generates this. We insert the rules on session, fire the rules, and then whatever hits, we ship off to the dashboard for processing. And that is all driven by this rule unit. So this is more Kogito stuff. But basically, you just declare the rule unit that knows how to process that type of data. So we know how to process health data, and then it all gets wired back together and tied back together from a business logic perspective.
Very nice.
Yeah, it's nice how everything is like less than 100 lines of code, it seems.
Yeah, it's very much a POC, but it is fully integrated, which is nice. So a lot of it too, I'm using Lombok just because I don't like to look at getters and setters, but it makes things really simple and clean as well. And then, okay, so any questions on that one?
We should have a panache for Kogito entities. I was just thinking out loud, like in JPA we had, or High maybe added a panache so you don't have to have getter and setters. I was just saying we should have the same thing for Kogito, so you don't have to use Lombok or something like that. But
yeah, you probably could do that. You might even be able to use the existing one. I'm not exactly sure how that works in Kogito. It works differently than it used to in Drools because they can't use as much reflection as they used to. So the last code perspective is this dashboard. So if we have the population health dashboard, as I mentioned, a lot of this is mocked from a graph perspective. I didn't have time to fill out all of the APIs for that. But the rewards data and alerts data are live, and we'll demo filling these out in a couple different ways in just a second. But this is all served up by Quarkus as well. So this is a static bootstrap template that makes a set of API calls to our service. And so it's fairly rich in terms of what it's got from a capability standpoint. And it's nice to be able to really quickly create something. This isn't a modern front end or a modern architecture. This is just basic jQuery and HTML. But you could do the same kind of thing with a React or Angular single page application. So if we look at the code behind this one, it's pretty simple again. A couple of APIs, so something that's listening for those alerts that we talked about, and then something that's listening for rewards. I've got some demo code in here. But simple models, so basic models, and then basic services to serve the data back up. So a couple of transactional services and these use Panache as well. So the models themselves are Panache entities. that we persist to the database. And so, alert and reward go out to the database, and then I have some category grouping that they're kind of partly finished. So it's it's a really simple API that you can use to drive the health data microservice. The decision service invokes this thing and publishes the data. And then if you look in meta-inf resources, you can see that static site. So there's all this HTML and JavaScript that's served up by Kogito on our behalf. And so it all starts at index.html. And this isn't meant to be, the front end of this was maybe the least focused. So if you're a front end developer looking at this, I apologize. It's probably offensive, but the goal was to focus on.
I just want to remind everybody that this code actually is open source. Everyone can go see it. It's on the hackathon under your submission. So anyone who wants to see it can do. So yeah. So how about
it's a great example too on how you how you use this kind of a use case. So there's a lot of nice techniques, a lot of integration with the frameworks. So it's definitely worth checking out. I'm sure Joe. Probably when you first started looking into this stuff, there was probably a bit of some learning hurdles. I mean, I know, we try to put some guides out there and try to make things as easy as we can make it. But we're constantly improving. We're not, we don't have everything together. So I'm sure being able to start from your example, if you had something like this, it probably would be really helpful.
Yeah, I hope so. I mean, I learned a lot. Different ways of thinking in the Quarkus world, some kind of old habits sometimes. And for example, learning about how Panache and Panache queries work and how Panache entities work. It's very JPA and it fits into JPA, but it's just different enough. You have to learn a new language, some new verbs essentially, about how it works. But the documentation on Panache is great. But yeah, if somebody wants a quick way to see how to connect entities up to a database, and persist that data, then this is a great example. And I will say, the Panache piece and the database piece was amazingly easy. Like I said, I haven't written code in a long time, and that used to be something that took days, right? It takes a long time to set up a database, and it takes a long time to figure out the queries and set all of that up. But Panache, I set it up in a few hours. I was able to add persistence to the application, and it just worked. There was no issue. I'm not doing anything really fancy. It's simple queries, but I was surprised how fast that came together once I understood the right way to use the framework.
Cool. So on the Lambda side, were you using native there, or how's the?
Yeah, so the Lambda that I deployed, and I can show it. I can't invoke it because I've lost the credentials. But I built a native image. I built a native image from the Drool stuff and deployed that decision out to the. If I can pull that code up actually in the decision services. So the only thing I really had to do for that was add a Lambda HTTP. So I added this and then followed the build instructions. So this plugin adds a bunch of scripts to the application, and then you run those scripts and deploy it. And it worked really nicely, kind of out of the box. And so I can actually show the scripts in the Lambda itself. But yeah, I built an image for the Drool stuff and published it out there. And in the video, I talked serverless for the ETL. I didn't actually deploy that one as a Lambda. Because I was going to add some capability to store Google credentials on S3. I haven't done that yet, but otherwise it would work as a Lambda as well. It has that same HTTP capability. So this is the Lambda here. So you can see it hasn't been invoked very much, only a few times, a few different test times. Like I invoked it once today, but this is that decision services endpoint built as a Lambda. And if I can pull up the Quarkus HTTP Lambda, but check out those docs, and they're awesome. The HTTP Lambda stuff worked amazingly. That's another thing I hadn't done before. I was brand new to Lambdas on Amazon. I hadn't deployed a function there before, and I got from zero to serverless Java in a pretty short period of time. So that tool is really great.
Nice. So just so getting right, so the stuff that is in the Lambda, was that the receiving of the data, and then you pass it on, or what was the thing you get there?
Yeah, so it's the business rules. Yeah, so this is the guy. This piece of the architecture here was the piece that deployed as a Lambda. So it builds the business rules and those APIs into into a native image. You push that native image out to Lambda, and then it runs. And then from the demo perspective, I ran this locally and ran this locally. But because it listens on an HTTP endpoint, I was able to use that same REST client library, so like the microprofile REST client. And all I had to do was put the endpoint of the Lambda into the properties file, and it worked. It was able to invoke it, and then this thing generates data and publishes it back to the dashboard.
Cool. Awesome. Did we get it all the way around the app? I think because it was surprisingly little code actually.
Yeah, it's not a lot of code. It's a lot of libraries. Like Jason was talking about, I use a ton of extensions, a ton of the Quarkus extensions, and all I really did was wire them all together. And again, it's a POC, like it's not meant to be a full scale application or anything like that. But yeah, it all comes together. We can run it. We can try it once here. Let me pull up command line. See if we can do this. All right. So we'll look at this on command line. So running here, I have the dashboard. I've got decision services, which is business rules. I have ETL service. And then we didn't talk about it. The mock is actually a fourth Kogito service. And all this thing does is if I don't want to run the ETL, so like setting up the ETL and getting connected to Google and making that all work is it's a pain, to be honest. Just like the Google side of it is a lot of work. And so if you don't want to do the Google side of it, you can use this mock service that will process data. So we'll see if this works. So basically that thing's listening on 8083, and then it's going to invoke the business rules. So just from an architecture perspective, swapping this thing out and replacing it with a mock so we can test out the business rules and we can test out the dashboard. So let's send that data and we'll see what happens. It's recompiling, there we go. So this is the decision service. So this thing, the self data mock, is loading data from a spreadsheet, so it has a CSV file in it, and then it hits these alerts. And so these are the business rules that hit for the data we publish, and I'll show you the data in a minute. But basically it hit that respiration alert. So this would be like the Nick Watney example from the golfing, or Mark Watney, I don't remember. And then these will go to the dashboard. So this is the decision service, we hit our business rules, and then if we go to the dashboard, and we go back to alerts data, we've got our alerts. So you can see we hit the 10% alert rule, the 20% alert rule, and the 30% alert rule. And they show up in our dashboard, which was empty a moment ago. So if we go back to the business rules, that comes from here. Basically, we hit these guys. We hit these rules right here. We've got some demo data in a spreadsheet that causes these rules to trigger, and then we publish it to the dashboard, and they show up. So it kind of shows the whole thing end to end, and then we'll see if the Google stuff is working. This is a little bit more of an ambitious demo, but we'll see how it goes. The idea here is that we would get redirected to a page that should, if everything's working, send us out to Google. So now I'm connected up to Google, and it's asking me to authenticate my account. So basically, I'm Population Health. This would be what we deploy as the PGA Tour. So the PGA Tour would have their instance of this, or Red Hat would have their instance, or Entando would have their instance. I pick my account, and then it'll send a message back to that servlet that we looked at just a minute ago, and it will trigger a bunch of data. And so if we go to the logs here, there we go. You can see it fetched. I have it set up to fetch all my data. So it's fetching all my step data going back a bunch of years. That gets pushed to our business rules. You can see we hit all these reward things for all the different days that I walked. Not enough walking is probably the lesson here. And then that goes to the reward service. And if we go to the rewards dashboard, we've got 598 entries. So basically it hit all of those business rules. And so end to end, right? You start from nothing, authenticate to Google, get that refresh token, use that refresh token to go out and get data, transform it for the business rules, publish that via REST. The business rules fire, take action. The output of the business rules is published to this dashboard, which again is just a microservice, a Quarkus microservice, and the data shows up here. So like end to end, not a lot of code, but it does tie everything together, and the integration is real.
All right. So
Awesome.
we're not getting questions, but I'll ask one thing. So you talk about all the good stuff that's in Quarkus. Is there anything we could do better, or something you were disappointed over, or what's anything we can learn?
I think I'd have to go back and look at the tickets I opened, but I think some of the documentation, the documentation is really good. So the documentation for the modules is really good. So like if you want to go do an HTTP Lambda, it's great, works. If you want to do Panache, great, works. There's kind of less, or maybe we need some more solution-focused documentation on how do you take all the pieces, how do you take Panache and REST Easy and JUnit and Kogito and put them together into something that solves a business problem, right? So how do you, some solution-focused capability or like examples like this one, like maybe this can be an example for people, but I found that like the modules were great, but I had to figure out how to glue them together, and that would be the main thing on the Quarkus side. And then on the Kogito side, I think it's still not 1.0, so there's a lot to do there. I think more Quarkus functionality around Kogito, like about the way the beans are structured, expanding some of the business process functionality and the ability to do BPM in Quarkus is going to be really cool. But yeah, the one thing that stood out to me was really, it's kind of, the module documentation is great. There's no bigger picture, at least that I saw. But no, I thought it was awesome. I learned a lot, and I think I was new to Grail, new to native images, and I had some problems, but like I said, everybody was really, really helpful. So it worked out pretty well.
Thanks. That's awesome feedback. I think that's definitely a big piece, is because one of the challenges, with yes, at Quarkus, we're trying to enable, it's like the next generation application development. So a lot of cutting edge stuff, a lot of cloud development capabilities and so on. And so one of the big challenges I can totally see is that if you come into it, you're thinking like, okay, well, which of these technologies should I be using for a particular use case? So yeah, thanks for that feedback. I think we definitely have some work to do, to make that better. But your demo here is great. It's a good. Maybe we'll borrow some of that.
Yeah.
In our guides. I had a question for you about it's your architecture is cool, and I just wanted to ask, because it may not be apparent to others, but could you talk about the scalability of what you designed and how that would work with load and so on?
Yeah, definitely. So, if you think about where those loads are going to live, in particular, like if you start with decision services, kind of in the middle. If you were the PGA Tour, or even a big entity, like if you were IBM and you wanted to monitor the steps your employees take for a reward program, it's generate a lot of data. And it's probably going to be as well. So in a lot of cases, so it's going to be all at once at a specific period of time. And that's why I think the list piece is important to this from an architecture perspective, is that the data is not all going to be, it's not going to be smooth. It's not going to be coming from a machine. It's going to be based on what people are doing and when they're syncing their devices and things like that. And so, the ETL service needs to be something you can scale up very, very quickly and then scale down very, very quickly, so that, just to save money, right? Because if you have to keep a server farm up just to process data once a day, it's going to be really expensive. And so I think serverless is a really good fit, just because it will scale up so fast. And as you think about the architecture, like a more complete architecture, something that you could turn into a product or take to a company, you would need some kind of persistence layer there. And so you could do that, you could do that with caching, you can use Redis or InfiniSpan or whatever. I was thinking about doing some of that on S3, because it's not necessarily a performance intensive application. That's kind of not going to be the main thing, but how do you process and get through all of that data in a meaningful period of time? So it's not, there are people that are waiting on the response, but you want to scale up and get through it, through that data and process all of it. And then the same thing with the decision services. That's all, that decision making is going to be something that you do for a short period of time, and then you want that data, you want those services to go away, and you want things.
We just lost him. Well, it was cool. It was a cool answer. Yeah, because that was one of the things I found really interesting, is that he combined, business rules processing with serverless piece. So, being able to kind of go from no traffic to responding and scaling up as demand increases, and then goes back down again. So you can kind of control your cost, is really going to be reflected on basically on what you use versus having to have a set of services, already running. Hey, Joe, sorry once again for the technical difficulties.
Where are you actually located, Joe?
I'm in Rome, Italy at the moment. So I'm based in Denver, but I'm actually sitting in Italy today.
Oh, okay. Because I couldn't. You had an American accent, but I was like, you showed up very early in email, so that was. All right. Anyway, we are actually heading down to our last few minutes. Anyone have a last question that can do? Otherwise, I just want to say, I think for those who don't know, we had the hackathon 2 months ago, a month ago, and we will try and get a few more on board. But there are this Joe's example here, which I think, like as you said yourself, but I think it's a great example of how much you can actually do with very little. It's pretty awesome. But there's also a few guys we're trying to get on in the next couple of quarters. Not the next one. Next week is going to be Kafka, I think. Kafka with Gunnar. And in a few weeks from now, we hope to get another one of the hackathon on. So how was the hackathon? It just went smooth for you? Like, all good? No, you got the feedback you needed? Everyone helped you?
Yeah. I was kind of late starting, so I didn't start or really even know about the hackathon until towards the end of June. And so, I only went to one of the office hours. But for me, like, I just went to the chat. Like, when I needed help, I just went to the chat and everything worked great. Dev posts worked really well. And yeah, I didn't have any trouble. It worked out really well.
Cool. Was it hard to come up with the idea, or is it something like when you saw the hackathon, you're like, I know exactly what I want to do?
I didn't know exactly what I wanted to do. I knew Kogito. So, like I talked about, I'm kind of crazy about business rules and rules engines in general. And so I knew I wanted to do something with Kogito. And I spent a long time working for a company that built healthcare software. And so, the ability to process health data and make decisions on health data was something many years ago. I had it for a long time. And so I just kind of made those two things up. And then I happened to read that article about the golfer, like the day I was starting. Like, I was just writing some code, and I thought that, and I thought, well, that'll be compelling to a hackathon judge, right? It shows a real world use case. And so, and COVID, of course, was top of mind, and so I jumped in there on that.
Do you have any tips that you would give to new Quarkus developers? Maybe there's some who are watching this show and thinking about what they're going to build or how they're going to attack a particular problem. Do you have any advice for them?
Start, I guess, would be the only advice. I mean, the thing for me, I did some reading and did the documentation, but I think with the way everything is structured in Quarkus, go write some code and then just jump back out to the tutorials as you go. The thing that worked best for me wasn't trying to figure out, as I mentioned, you kind of have to figure out all the tools that you want to use on your own. And I think the best way to do that is to just start and then replace stuff as you want to, or add new functions, add new plugins, add new capabilities. So, Quarkus does a good job of making it pretty easy to add new modules and add new add-ons and bring new stuff in. And so I think the best thing to do is really just dive in and write some code, and then don't be worried about coding yourself into a corner, because it does a good job of keeping things changeable.
And did you use dev mode, or was it just test run, or?
Yeah, I use dev mode a lot. I use dev mode a whole bunch for almost everything. Actually, I actually had to break some habits. So I'm used to changing a piece of code, Control C, start things back up again. And I found myself killing Quarkus while it was trying to do me a favor.
I still do that.
It's reading the code. I'm watching it reload code, and then my fingers, they have a mind of their own. Just kill it, start over. But you don't have to do that anymore. Yeah. It's a new world, right? If I can learn that, I'll double my productivity. If I stop killing stuff that's trying to reload for me, I'll be in good shape.
That'll be good. Okay, well, Joe, congratulations, and thanks for all the efforts, and thanks for joining in, and sorry for the technical
no worries.
challenges, but this was good. So,
appreciate it, guys. Yeah, and if anybody out there has any questions, feel free to throw issues on the GitHub stuff. I'm happy to try and help. I'm no expert, but I'd be interested to see if anybody else can get this thing running.
Awesome. Cool. So thank you, everybody, for today's show. Once again, there'll be some information in show notes. We talked a little bit about the Java issue, and Joe's in the community. And so, just come reach out to us on chat if you have any questions. And, of course, you can always go to Quarkus.io as your central entry point to find everything that you need. Thanks again, everybody, and have a great rest of your day, depending on whether it's afternoon, morning, evening, wherever you happen to be. Thank you for attending our show, and have a great day.
Thanks, guys.
Thank you.